We have now discussed master production schedule and bill of materials. So next let's look at the inventory records. So inventory that's available in stock, and we have to have accurate inventory records in the system. We talked about cycle counting in chapter 12, and that's very important. So if you need to do cycle counting to make sure that the inventory record that is in the computer is accurate with the actual physical availability. So accurate inventory records are absolutely required for MRP or any dependent demand items to operate correctly, and any mistakes there. Generally MRP systems require more than 99% accuracy, because even if there is small discrepancies, the computations are such that a lot of snowballing effects will occur, and you'll end up with plans that are not accurate, that are not useful. Now the fourth item is the purchase orders outstanding, and this is called scheduled receipts, and these are items that are not in our stock but they're going to be in our stock. There is a promised delivery date for these items. The fifth component is the lead time. So the lead time is if it is a vendor order, it is the time between you placing the order and the order coming in, and if it is production order, it is the sum of all the wait time and cycle time and production time and everything included. So the time between you placing the order with the shop floor and the time when the order is completed and the stock is made available. Here is an example of components that the bill of materials that we saw in the previous video, and for each of these items, okay, A being the top level item, and these are the components, and if these are the lead times, now one thing we can do is try to figure out what is the overall lead time to producing the final product A. And remember, that is not simply a sum of the lead times, because some of these items can be produced in parallel. So you cannot simply add up all the lead times and say that is the overall lead time for producing the final product A. So we have to develop what is called time-phased product structure. So time-phased product structure, we have time on the x-axis, and then y-axis it doesn't matter, there is no y-axis actually. So you plot the items according to the bill of materials. So you take the bill of materials, which is top to bottom, and then just rotate it 90 degrees clockwise and make sure that these lines are lead time based on the scale of the x-axis. So once you build that, then you start from the leftmost point. So this is the starting of week 1, and then you number the weeks all the way down this way. So now week 7, the 8 here is the big end of 7. It's not week 8. So remember, we are starting out with 1 here. So the beginning of week 1, beginning of week 2, and so on. So this is the beginning of week 7. So the overall lead time is 7 weeks. If you simply add the lead times, you'll get 3 to 5, 5 to 7, 12 weeks. But in fact, the overall lead time is only 7 weeks, because some of those weeks are done in parallel.